Hi everyone. I believe this is lecture 20 of the course. So today's lecture is about the Earth through the Anthropocene, right? And so just like this presentation will be brief. So it's also a continuation of the previous climate change lecture, but I would like to put what we're seeing today within the geological time frame, right? So, and define what the Anthropocene is, right? But first, if we look at the climate history of the Earth over the last 65 million years or so, we see significant changes, right? So you see that what you see here is, for instance, the Paleocene, the Eocene, the Oligocene, the Miocene, and then recently what we call this Quaternary period. So these are two geological time frames, right? The time frames we use to categorize each and every geological event, right? So how these geological time frames are defined is because each geological time frame have its own fingerprint, right? So for instance, if we're looking at the Paleocene, so we see that, like, of course, the climate, the temperature, especially if we're looking at temperature wise, the patterns are different, right? So, and then the Eocene, where we have, because of the it could be different reasons, because of the realignment of the continents, where we see a constant drop in global temperatures throughout the ocean, right? And then the Oligocene period, of course, we do see these different cycles, and then we're back to Miocene, where we do see again a constant trend, where we are going to a continuously global cooling period, right? So each geological time frame has its own fingerprint, right? So today, what we call the Anthropocene is the time period, the geological time period where humans have started changing the planet, and which is completely different to the things that we have seen in this planet. So humans, it's the Anthropocene, it's the period where humans within that geological scope became much more relevant, right? So then we humans, the human species, have started putting their own fingerprint, right? So what happens today is, if we're looking at the change that we see today, for instance, in terms of population, of course, the Anthropocene is very, very different, right? So what we see is the population doubling every 44 years, right? So we have this exponential growth population, but most importantly, what we see today is a significant and rapid rise of carbon dioxide levels in the atmosphere. So we don't really have a precedent to what's happening today in the geological past, right? So humans, our species, are putting their own fingerprint in the geological timescale, right? So what we're seeing today, if we continue doing that, right, for the foreseeable future in terms of geological time scales. So we'll be able to see that fingerprint as we have seen it here for the Paleocene or the Eocene, where we have started that significant rise in temperature again, right? So completely different, because the scale of time, so the rate of change is unprecedented. So it has been taking, these are geological time scales. So these are processes happening over millions of years time scale, right? And then even when we're talking about those changes in orbital parameters, like eccentricity, obliquity, precession, we're talking about changes that take place over tens of thousands of years, right? But what we're seeing today is the start of the Anthropocene, where we have initiated this unprecedented global warming, right? So it's going to have its own fingerprint, right? And then the Anthropocene is unique in a way, because these fingerprints have we do have humans have their own fingerprint in the environment that's also going to be buried in the geological record, right? So, for instance, in the Anthropocene, we're seeing this incredible rate of warming that we haven't seen, and because of the greenhouse gas emissions. So the type of emissions we have, the type of greenhouse gases that we're talking about are actually human generated, right? So the gases are from fossil fuels. That makes it completely different from past warming and cooling episodes that were recorded in the Earth's geological past, right? And so if you look at the combined anthropogenic forcing, well, pretty much exclusively the warming that's happening today is caused by the greenhouse gases. But in these figures, I would like to bring your attention to this. What you see here in yellow, we do also emit other particles from fossil fuels, right? So, for instance, that tend to cause cooling instead of warming. But the overall impact of the greenhouse gases, the greenhouse gases I mean by methane or carbon dioxide, they easily counter the amount of cooling that may be caused by some of the particles that humans are emitting to the atmosphere, right? So the end result is a continuous rise in temperature and global temperature because of the increase in carbon dioxide levels. So today we are about 400 to ppm, around 420 ppm in the atmosphere, right? So this rate of change, it's something that we haven't really observed in Earth's vast geological past, right? So it's enough evidence that like to suggest that we are actually on a different geological time scale. Like the Eocene, the Paleocene, the Miocene, we are entering a geological time scale, and then over the course of billions of years, then the next species will be looking at the starting of the Earth's incredible warming, right? So there are in the Anthropocene, of course, what we are witnessing is a complex processes through the carbon cycle, both in the atmosphere and the ocean. So more and more carbon dioxide is being absorbed by the ocean, of course, and then this is resulting in unprecedented ocean acidification. And this is only given the time period that this is happening. It's actually we don't really have any reference in the past to compare to, right? And for instance, if you compare the ocean pre-industrial versus projected, and then you'd see that like we're actually pushing the ocean to become more and more acidic, and then this would have enormous severe consequences for the marine life as we know today. But most importantly, what we see in the atmosphere is this unprecedented warming, and because of the addition of carbon. So here in this case, I'm showing you data from the early 1900s to the present, right? So and what you see here, again, as I've discussed in the previous lecture, significant differences in the extent of warming between the northern hemisphere and the southern hemisphere, because, again, much of the land mass is concentrated in the northern hemisphere, right? So all this evidence is like the extent of warming, the extent of loss, the ice, the extent of ice that we are losing today. It's actually, and then the time rate, given that it's actually, this is happening on a much shorter time scale as a fingerprint of the Anthropocene. So it's we have actually entered the Anthropocene. When exactly the start of the Anthropocene? Well, it is still debated, but we can actually build consensus on the start of the industrial revolution, probably in the 18th century, right? 18th or 19th century. So, but the most important thing is to even on a geological time scale, that it's actually we have all the evidence to suggest that we have already entered, or we have already about to enter, and to embark on this different geological period where things are significantly changing at a much faster rate that nothing similar to we have seen in the geological past, right? And of course, whether we're looking at the extent of warming in the atmosphere, or the extent of the rapid acidification of the ocean, which tend to eat up the calcium carbonate that's already available in the ocean, where the different marine species use to build their own shells. This as fingerprint of this is those conditions that we observe, those cases that we observe during the Anthropocene period, right? So in a way, taking you back to the first figure, even geologically wise, so if we're actually going to continue along this trajectory, it's clear that the Anthropocene would be a very consequential and then very critical geological time period for the survival of the human species. So this will be the end of lectures on the climate series. So on next lecture, I will briefly summarize what we can do the things we should do to tackle to counter the climate crisis. And so it will be more lecture will be more tailored to solutions, in a way, finding what are the available solutions, what are the available mechanisms that we have at hand to fight this unprecedented warming that we are experiencing today. Attendance quizzes will be posted as soon as this lecture is posted. Please make sure to watch all the lecture videos in full before you attempt to answer the questions in the attendance quizzes. Right? All the best.